Hi friends, in this presentation we will be considering the modeling, analysis and design of lift wall for a 4-story building hotel successfully. If I should activate the analytical model of this sample of this lift, I will select these animations and you can see the behavior of the load on the lift successfully. Okay, so we are going to be considering the modeling, analysis and design. Once again, you are welcome. This is Soft Reason. Don't forget to like the lesson and subscribe. Let us get started. I will navigate to the file menu so as to create a new project. I click right there, then new project. In the new project dialog, I will save this particular one and be able to give my project code name as lift where just like this. Okay, then I'll scroll down and then I'll be using UK hero codes. Okay, just like this. Click on the OK option. Alright, so here is a new project template. So we are going to be considering the grid lines set out for the lift successfully. So what I have here, we are designing a lift mainly for the transport of persons in which goods may be carried, and the rated speed is up to 0.75 meter per second. The rated load is up to 700 kg, and you have to note that 1 kg equals 0.009807 kilonewton. Applications: 4-story hotel building. Lift wall dimension is 2025 millimeter by 2025 millimeter. So this is the dimension we are going to be considering as we will be setting out the grid lines successfully. So I will minimize this. I'll go to the modeling tab right there, click on the orthogonal exit generator. I'll pick this point. Now in the direction 1 axis, which is the axis level A, I will be having a dimension 800, which is a clear support distance for the foundations. Okay, then I'll input comma, and then I will have the lift well dimension, which is 2025 millimeter. All right, comma again, and then 800 for the clear support distance for the foundations. This same thing is what I will be having in the other direction. So I can just come to these provisions and then input in 800, all right, comma 2025 millimeter, all right, comma, and 800, just like this. After which, just have to click on the OK options to have it just like this. All right, so with this now, we are good to go with our modeling. So I will go straight away to the wall, click right there, and in the wall dialog, the thickness of the lift is 225. 225 is the thickness. Okay, so half of 225 you will have 112.5. All right, 112.5, which is half of 225. So you need to provide it 112.5, just like this. All right, so with this we can now begin to draw the first lift wall that will connect the first floor and the foundations successfully. So I'll pick this point up to this point, place it there, and this point, and this point. After which I will click on the cancel options right there. So now we have this, and in this lift wall we have an entrance into the lift, a door which is 1 meter, okay, from this side. Okay, so we are going to be creating an opening here of 1 meter. So you just have to select it, right click, and then come to wall opening editor, click right there. So you have this, and then just click on the add options. Then you have 1 meter in the width provisions, then in the height provisions, the height of the door is going to be 2100, just like this. Okay, while in the y directions we are having it to be 0, just like this. So you'll be having a door. There's an entrance into the lift. All right, so these are the settings. Okay, you just have to click on the OK options right there, and then that is done successfully. You want to see it, navigate to the 3D, and you have something of this kind. Okay, so meaning from this distance, this is the DPC level where you can get into the lift, and then it will be transport you or elevate you to other stories. Okay, and this is for 4-story hotel building. Okay, so we want to be doing some other settings, like we will be considering our foundation depth as well as the number of story insertions. So for us to do that, select stories, right click, and then click on the insert stories. So the number of story we'll be considering is 5 stories. Okay, so click on the OK options, and then yes option, just like this. So we have up to 5 stories, just like that. Okay, then we go back to the story, right click, and then edit stories. In the edit story dialog, for the foundations, we will be having a foundation of 1250 millimeter depth foundation, just like this. Okay, for the height of the structure is going to be uniform, which is 3 meters. So we have up to 15 meters altogether. All right, just like this. Click on the OK option to have that done. So we navigate to the story one right there. So with this story, we can now generate this lift well to other stories. Okay, so what do? You go straight away to this provisions. You have story, like right click, and then click on the generate stories. In the generate story dialog, the target stories are story 2, story up to story 2 to 5. Okay, while the source story is this story 1 that we have already modeled. Just have to click on OK options to get it generated, just like this. Successfully it's completed. So click on the close options, and then you will be having something of this kind. This is the first floor, second floor, third floor, and fourth floor, just like this. Okay, so we are at the top roof of the lift well. So just have to navigate to the plan view of that top. So this is the top of the lift well. We need to provide a slab here. Okay, reinforced concrete slabs. So click on the slab options, and then in the slab thickness we have it to be 150, just like this. Okay, and then the cover is going to be 25. Come to the load. All right, additional dead load we have it to be just 2. Okay, and then we have it to be 1 as additional dead load. Imposed load is for commercial building. Okay, so for commercial building we may be considering 2.5. Okay, 2.5. Can use hospital word as well, but let's go by 2.5 kilonewton, okay, per square meter. All right, so for the roof load we will consider it to be 1.5. okay, just like this. We are okay with this, so we just have to click inside of this provision to insert the slab, just like this. You can see, after which click on the close options and navigate to the 3D. So this is what we are having. All right, so after getting this done, the next thing we are going to be modeling is the foundations, the rough foundations. Okay, so we navigate to the story 1 and then get straight away to the story 0, just like this. So we'll be providing foundations. So because we will be considering our foundations to carry the lift. Okay, so we navigate to the plan view of the story 0, so we can be able to model the rough slab for the rough foundation. So go straight away to the slab options, click right there in the option dialog. We provide a slab thickness of 350, just like this. Okay, and then the cover is going to be 50 millimeter. Come over to load. In this load provisions, where we have an additional load. In the provision of an additional load, we are going to consider the weight of the lift, because the weight of the lift is being transported to the foundations. So we are going to be considering it. So if I open what I have here, the lift is up to 700 kg. All right, and note 1 kg is equals to 0.009807 kilonewton. So if you're having 700 kg, we are going to multiply 700 kg by this figure, and then what do we have? So our calculator, then we have 700 kg, 700 kg just like this, multiply by 0.0090807 just like this equals. So you're having 6.86 approximately. Okay, 6.86. This 6.86 is a point load, it's in kilonewton. All right, so we want to convert it to an area load. Okay, we want to convert it to an area load. So to convert it to an area load, you have to multiply this point load by the area of the surface you want to distribute the load successfully. So the area of the surface we are going to distribute the load is 2.025 by 2.025, which is 2000. This value, this is the area, this one. Okay, this is the area. So let us check what is this. Okay, this is 2.025 by 2.025. okay, so come to these provisions, take note of this figure. This is 6.86. all right, so we have 2.025. okay, multiply by 2.025 just like this equals. So this is what? 4.1. So we have 6.87 divides 4.1. let's just go by that. This is equals, you have a 1.6. so we are going to be distributing the load of this lift in terms of area of the surface by 1.6. all right, so I will minimize this and minimize this, and in this provision where you're having additional dead load, okay, for the lift we're having it as 1.6, then plus other factors. So we take other factors to be 2 kilonewton per square meter. So 2 kilonewton per square meter plus 1.6, we are having 3.6 kilonewton per square meters. Okay, so additional dead load is going to be 3.6 just like this. Okay, so an imposed load we will be considering this. Okay, hotel and motels. Okay, considering this, all right, on the foundations. So after which we want to start to place the foundations slab. You can see a clear support distance, okay, to the lift well just like this. So we are going to be using an insertion method, pick axis insertion method, this one. So I'll select that, pick this first axis 1, then pick this axis D. I'll pick this axis 4, pick axis A, and then axis 1 again to insert the slab just like this. Okay, after having that inserted successfully, let's look at it in 3D. So this is what we'll be having. All right, this is the foundations. The slab looks transparent. If you want to make it to be opaque, okay, you just have to navigate to the building set out, click on the settings, click on the layers, scroll down, and then you will see slab. This one, change this to this color 8, and then you just have to adjust the opacity, click on the OK. So you have this just like this, after which we want to go into the analysis. So before the analysis, we will be enabling the loading combinations successfully. So we go to the loadings right there. By then you have to save the project, after which you click on the load case and combinations. In the load case and combinations loading generator, we also be having horizontal load, which is the wheel load, after which click on the OK. The load is generated successfully. You click on the OK options, you go to the wheel load. All right, and then wheel load calculator. What we need here is the basic wind speed in meter per second. So we'll be having the basic wind speed to be 50 meter per second, just like this. The terrace and the surroundings can be adjusted based on the construction site successfully. Click on the applied. So that is being applied successfully. Click on the OK options. Then we'll be going to the analysis tab, because we are going to run static analysis and as well as finite element analysis for the foundations. So go to the analysis tab, click on the building analysis. In the building analysis dialog, the project parameter we are going to set it successfully. You can see these are the codes we are using, hero codes. Okay, just like this, and then we go to the foundations. For the foundations, we are having the foundations so here stressed to be 100, just like this. Okay, for the title of the project is a lift well design. Lift well design. Okay, just like this. You can input other provisions, click on the OK options. So after which we'll be editing this material, so you click on the edit material. So in the edit material dialog, for the strength of the concrete, we are going to be considering C20/25. We are applying it to all of the provisions. Okay, then for the steel strength, we consider 460, just like that. Apply that, click on the OK options. All right, then for the concrete wall, which is the lift well, for the rebar diameters, we wouldn't want, we have to remove lift 8. We wouldn't want 13. If there's any 13, 32, we remove that. Okay, click on the OK options. Longitudinal width bars, we off 32. Okay, let there be 25 in case if there is a much load. Click on the OK options. Horizontal bars, we also off 32, and then leave the rest at default. Click on the OK options. For the links, we will be having our links to be 10 and 8. Click on the OK. For the slabs, we will be having 12, 16 right there, and 20. You just have to remove. We're also having 25 in case of eventuality if the load is much. Okay, click on the OK options. After which you go to the foundations right there and change this to C20/25. Click on the OK options. For the soil grade, 460, steel strength 460, and then for the rebars, we are having 12, 16, and 25. Go back again to this default. We are not necessarily checking for column, but can just select rebars for columns. Okay, because sometimes the program reads columns and walls as the same property, so you just have to check rebars for column in case it uses the columns templates to design it. All right, so let's just check this back. 32, 25. So just have to click on the OK options and then the OK again. After which, close this dialog and then save the project. Now the project is saved successfully. You need to go back to the analysis tab again. In this analysis tab now, we will go to analysis tab right there, and then you have to check the project. Click on the building model check, start checking. If there's an error, we have a 0 error, so we are good to go. Click on the closed options. After which we want to be carry out the analysis, okay, of the lift well. Click on the building analysis and then select design, column/wall reinforcement design. Okay, so it's get that selected. We don't have beam in the system, we don't have steel as well, so just click on the building analysis. Let's give the program some seconds to carry out the analysis successfully. So building analysis completed successfully. Related story drafts satisfy the limit. You can see, click on the close options. All right, building analysis completed successfully. All right, so you just click on the close option again and then you close this dialog. So you will be having this. All right, so this is the lift. Okay, so if I should activate displacement, you will have this. Okay, and the displacement. You check the relations. So this is the behavior in respect to the loadings applied on the lift. Okay, so you can also navigate to check the contour All right, just like this. The solid contour M12, the moment. All right, to see if there is any dangerous conditions or failure on the lift. Check the solid model as well. So just like this, everything is okay. The lift well has been analyzed and designed successfully. So we will be going back to the story 0 physical model, so we can be able to check the reinforcement of the lift. So navigate to story 0 and then enable story 1 right there. Come to shear wall, this one, select it, right click, and then use this option RC column / wall design. So we have this, expand this one. Okay, this is what we have. So we have to carry out bash mode analysis, bash mode design. So click on these provisions and select the first options. Click on calculate. Then click on closed. This can be calculated successfully. So you have to go back again, ask the program to select all bars. This one, click on calculate. After which you close. So you will notice this has not been designed. Okay, so what you will do, once you must have tried this and it does not work, you have to design it one by one. The first one, come to interactive design to check if you notice this has passed design successfully. Click on the interactive design. You can see this has passed design. Click on the OK options and the OK option that has been designed successfully. So you are going to interact it one by one. That is updating these things one by one, just like this. Okay, all right, you can see it has passed design. Click on the update. Okay, just like this. Interactive design. Okay, okay. Interactive design. Okay, and okay. So after you must have completed the reinforcement updates, just like this, you see all of the design as all of the wall has passed design successfully. You just have to close this dialog. All right, after which, if you come to these provisions, you will notice that you're still having a failure sign. What you just need to do, you just have to refresh this and then you check back. See, now it has passed. Okay, so the wall has passed design successfully. If you select there to check the reinforcement of the active story, this one is using for T12. Okay, this particular wall 1, okay, it's using 4012, and then wall 2 at story 1 is also using 48. Okay, and then you can see the links right there as specifically 300 T8. Okay, just like this. Click on the close options. Now we want to be designing the foundations. For the foundation design, we navigate to story 0 and then select this, right click on the plan view of that. In the plan view of these foundations, what you just need to do is we will have to draw a finite element strips. So we navigate to the modeling tabs. Here we have slab strips. Click right there in the slab strip dialog, select in the type and then select FE strips like this. Okay, come to the FE. We'll be considering this one. All right, this one. So we are going to be drawing it right away. So pick the first point here, move your cursor over to this other point with the control key to have a straight line, just like this. This provisions should be the center of the slab. Just have to click. Okay, here is the center. Pick that point and then pick this point to exactly just like this. So we need to expand this to get to this edge and this other edge. For us to do that, you have to select this provision. See this provision here, pick these provisions and pick the edge, then click on the update. It will expand the strips to that edge. You can see the same thing applicable and then update. Right, just like this. Mind you, we are in the X direction, so we are going to be draw it in the y direction. So you activate the y direction right away. Go to FE and then pick the first point right there. Pick the second point to have it drawn successfully in the y direction, just like this. After which, just have to click on the update and close this dialog. Now we are good to go for the foundation design. We navigate to the analysis tab. This time around, we are going to be dealing with FE Raft Foundations Analysis. So you click on right there. Okay. We have to use the subgrade reactions. Click there. Include column sections in the FE mode. Select right there. Okay. After which, click on the foundations, mesh, and analysis. After which, the problem will take us here. So you just have to zoom to have the surface you are analyzing and as well design. So click on the generate mode right there to have the surface of your slab mesh just like this. After which, click on this close button. So it is going to transfer us to an interface analysis post-processing where we can be able to continue the analysis. So click on the analysis post-processing right there. So you will be having this. Okay. So this is the foundations. All right. So with this, you just have to activate a standard contour. After which, you begin to apply the moments. Okay. X, Y, MX, and Y, just like this, and then M1 to 12. Okay. After which, design moment, bottom 1 to top 1 and 2, just like this. Then area still required in the first direction, top and bottom. Area still required in the second directions. If the sections of this raft slab is insufficient, the program will actually let you know. Okay, so you just have to check that successfully. So everything is okay, just like this. You check the soil pressure as well. The soil you can see here, okay here. So the soil in respect to the pressure coming from the slab is okay. Everything is okay. So the raft slab has been analyzed and designed successfully, just like this. Okay. So you just have to click on the closed provisions, this one, to have that closed. Then you have to transfer the FE strips successfully. Click on the OK options to have that transferred. So analysis and design of the raft slab is done successfully, just like this. Click on the close options. Okay. So after which, you just have to click on the update steel bars to generate the steel detailing of the reinforcement detailing of the raft slab. Click on this update steel bars. So you can see once you click there, you have your bars being updated just like this, top and bottom. You can see. So if you check very well, these bars are not being mentioned. There, it has not been mentioned. It's just T12 at 125. You can see spacing. All right, in this direction, while in this other directions, T12 spacing 200. So you can see. So I wanted to have a kind of like T12 should number the bars that is spanning within a particular directions. So for me to do that successfully, I have to go to set out and then come to settings. Okay, settings center. All right, for the provision where I have slabs, I can come to this provisions and then you see show number of bars in bar label. I'll click this provisions, after which I click on the OK. So you will notice that we are having 29 T12 now at spacing 125. Okay, center to center, spanning in these directions. All right, so the raft slab has been reinforced successfully, just like this. Okay, navigate to the 3D. So we have something of this kind. So we have successfully modeled, analyzed, and designed this lift well successfully, just like this. In the next lesson, we will be considering the drawing. I will show you how to do drawing, a complete drawing of this lift well successfully. Like the lesson, subscribe, and stay tuned. See you in the next lesson. Bye for now.